So what we're going to be measuring here is the temperature change associated with reacting magnesium oxide, NaHCl, and magnesium wire, NaHCl. Okay, so what we're going to do is we're going to first measure out 0.5 grams of magnesium oxide. We're going to use a set of weighing paper. Okay, we're going to zero our scale. We're going to put our weigh paper on the surface. We're going to zero again, and then we're going to add our 0.5 grams of magnesium oxide to the container, or rather to the weighing paper. Okay, so add a little bit at a time. See how that goes. Okay, a little smaller scoop this time. So it looks like 0.53 grams, 0.52 grams is what I've measured out here, as you can see. Okay, 0.52 grams is what it looks like what we have. Okay, so what we're then going to be doing is we're going to be measuring out 50 milliliters of 1 molar hydrochloric acid. I've already done that into a graduated cylinder here. Okay, I'm then going to place it into our container, our calorimeter container. So I'm going to add that. Okay, I'm then going to take my setup here. I have a temperature probe, and I have obviously the temperature reading here. I'm going to lower that probe into my hydrochloric acid. Okay, and I'm going to allow the temperature to stabilize. Okay, as you can see here, so this is going to be our initial temperature of our reaction, our setup here. Okay, and then what I'm going to do is I'm going to add my magnesium oxide to the container, and then I'm going to watch the temperature change. I'm then going to record the maximum temperature or minimum temperature, depending on what direction this goes, as my final temperature. So I'm going to go ahead. Swirl. Looks like our temperature's continuing to change. So we may have some stability there. Okay, so it looks like we did reach our maximum there. Okay, so that is our initial trial run, or our initial run with magnesium oxide and HCl. Okay, you saw initial temperature, you saw final temperature, you have your mass and volume of each species, so you should be able to take this and get the information you need. Okay. Okay, so before we start trial number 2 with our 1 molar HCl and our magnesium wire, we first need to take care of the previous reaction mixture situation. Okay, so first of all, we stuck the probe into the solution, so we need to make sure we rinse the solution down really nicely. Okay, rinse and dry. Okay, make sure that there's nothing remaining on the probe. Okay, I'm then going to take the reaction mixture. Okay, I'm going to put this into the appropriate waste container. It's off camera, so sorry about that, but I'm going to take that and put that where it needs to go. Okay, then what we're going to do is we're going to go ahead and we're going to get the new container. We're going to, once again, add 50 milliliters of hydrochloric acid. Okay, so nice clean container. Okay. We're going to stick our probe down into the liquid, and we're going to allow it to basically measure the temperature of that liquid. So we're going to give it a little bit of time, make sure we've allowed the temperature of the liquid to be determined here. Okay, and that's going to be your initial temperature. Okay, so give it another couple seconds here. Looks like we're pretty well established. Let me put a little lower down into the mixture. Okay, make sure we don't see a change. Okay, so that's going to be our initial value. We are then going to add or place our magnesium wire on the scale to see its mass. Okay, so it looks like we have 0.24, 0.25. Nope. 0.24 is what it looks like. Okay, so 0.24 grams is the mass of our wire here. Okay, it looks like we did get a slight change in our temperature here on the probe. Okay, so I think we probably had enough time. All right, so then what I'm going to do is I'm going to add the solid into the mixture. We're going to once again watch the temperature change. Now I want you guys to notice in this reaction what you see. Maybe here, it might be hard, but there's a little bit of fizzing happening. Go ahead. You guys can kind of see that, right? You got some bubbles there, definitely some fizzing. Okay, if we go back to our zoomed out mode here, we can monitor the temperature, see what's happening there. Looks like we are getting changes. Okay, we definitely have a vapor that's coming off, has a very pungent, kind of acrid smell to it. Try not to inhale that. Step away a little bit. Allow this to kind of run its course. Okay. So again, guys, you have the probe there. It's sticking down into the reaction mixture. Okay, we got our temperatures changes that are occurring here. So once again, we're going to watch this. Keep an eye on it as it's going along. Okay, so looks like we continuing to have temperature change. Okay. Like definitely have a lot more bubbles. You guys can kind of see the gas that's coming off. You can see it coming off the sides of the container. Okay, still we're getting temperature changes. Swirl, let everything interact. Nice temperature still rising, it looks like. Definitely still have a little bit of solid in there that's reacting. Okay. Kind of swirling around, making sure we're bringing up excess reactant up to the surface so it can react with that metal that's on the surface. I think we have reached our maximum temperature. You guys saw that earlier. Go ahead and record that. Okay, and then what we're going to do, of course, just like last time, we are going to disassemble this entire setup. Okay, we're going to pull this up to make sure that we have isolated it from the reaction mixture. We're then going to rinse down the surface, wipe it down. Okay, and then we are going to dispose of our waste container, or our waste in the appropriate waste container.